Oh.
More effective. Now I'm that's right.
Yes, in both database, yeah. So you like 22.
I have to change. Actually, just but I have to go from these lights. I have to remove from these lights.
Basically, you have these capturing your screen.
Oh, in fact, actually, you know what? I don't.
Because like texting or driving or all the all have
No, but that's not good. Oh no, that's bad. But it's not a fail. It's not a fail.
it's doable, but maybe not one afternoon because of other people.
Why don't you just plug in
That's right. I mean, worst case scenario, maybe I can use the computer. You know what? I'm gonna do first take off.
Yeah, this is it. Now it's just not a.
Yeah, but it's not. I'm keeping this going. And, should I? Do you think I should change the?
I think you should go out of Crowdcast. And, I do not know, but it's it's good, and he should be plugged in. For some reason, it's okay. Good. It's picking it up now. So if you now start presenting, it should be good.
But you were in the session.
Yeah.
Yeah, I think that's what we
Thank you. Awesome. Okay. Hey guys, only 5 minutes late. It's fantastic. Hello. Welcome and thank you for being here instead of in the awesome future of fMRI. We all know that the future of fMRI is physiology anyway, so you just skipped a step. That's great. Hi, I'm Stefano Moya. I am one of the members of the Physiopy community, and you're here to the Physiopy Tirana New York 8 and Enigma Half-Pipe present physiology community practices and challenges for small collaborative software projects. And since we are so little, if you just want to jump here, and we can just stop using microphones as well, it's fine. So the first part would be just a Physiopy open meeting in which we invite you to just jump in and give your opinion about physiological topics. And we're going to try to run it a little bit in a frisky way. It's honestly the first time that I'm going to try to run something like this, so bear with me. If it works, hey, we did a great job. If it didn't, it's just like, learning curve. But we're going to talk about some community practices that we can implement in order to get better physiological data. And so feel free to just jump up and join me on the stage or at this microphone, or if you're too shy, just you can take the microphone that points toward the auditorium, and just give your opinion about things. The second part of this meeting will be like we will have Dan, Neha, Dominique, and Leah joining me at the stage, and actually Dan will take the lead, and I will just be a member of the panel, and we're going to discuss about what happens to like little communities like ours, and what are the challenges that we face, and what are the problems that we can face together, and what are the solutions that some of us found, or the not solutions that some of us found, and then we can just talk about it, and it's going to be great. Before I start, I'm actually going to skip a bunch of slides because most of you already know what I'm going to talk about. But Physiopy is this community that was founded in 2019. We were like, oh man, like physiological imaging is awesome, and using physiological data together with neuroimaging data, it makes it everything better. What can we do in order to convince everybody else that that's the case? And we were like, okay, let's start by helping them collecting this data, convincing them to share the data, and help them to share the data, because that's not easy at all. And then we started collecting data, we started collecting toolboxes and creating documentations that people could follow. And that sparked a community, a little community that now is about 35 members that contributed throughout the 4 last years. Active members, it's more probably like 5 or 6, which is something that we're going to talk about later. But yeah, so we started meeting, we started talking about what are the best practices, or better, as I said before in the meeting, the worst practices that we can do, and let's try to avoid those. We have a bunch of aims that are very friendly, and it's basically just trying to make packages that make your life easier and our life easier as well. And also helping set a standardization set for this type of data. And actually, in the end, it was just a fun project to start learning some Python coding, some Git coding, some use of Git and GitHub, and start collaborating together. We have 4 core components, and all of them are super, super important for us. One is the user-friendly toolboxes that we are maintaining. The other one is the approachable documentation that hopefully will be approachable. You will let us know, please. And then a collection of community practices that we keep discussing and keep updating, because, stuff change and we don't know what the solution is. And then our fantastic community of users, developers, and researchers that help come up with all of these ideas and this software. We have a lot of libraries. I'm not going to go too much into detail with them, but they're basically they are supposed to help you putting your formats, your physiological data formats into bits, and then do some post-processing and modeling to use physiological fluctuations inside your MRI experiments, either as a friend or as a foe. It's up to you to decide. On top of that, we started talking with other software developers, and we were like, oh man, it would be great if we could have a standard set of data that we could use to test our programs and see if they work. And so that's a work in progress. Another work in progress is PhysioQC, a toolbox that helps you taking some quality control decisions, let's call it like that, yeah, informed by some metrics and some images, and then possibly some funky stuff happening in the middle. And most importantly of all, actually, it's our documentation and the interface between this documentation and the rest of the software. That, I think, it's one of the strengths that we find out by doing it. As I said, there's a lot of work in progress. I'm going to skip that. And first of all, a huge thanks to all of the Physiopy contributors that are in this room and that are not in this room, because you guys, you made this happen. So awesome. By the way, if you can stand, raise your hand if you're a Physiopy member. Hi. Okay. Those are fun people. Speak with them. Just that. Offer them a beer if you're around them. Okay. So, as I said before, we're going to do stuff in the freaky way. In the freaky way, yeah. It's a way to say it. It's very confusing, I know. So what I would like you to do is to use your computer or your laptop, same thing, or your phone, go on that website and add that number. And I know that it's a bit cut, but if you can also use that QR code. And once you're there, please let me know, raise your hand if you're there. I see 40%. Okay, I'm going to give you a little bit more time. Awesome. So, in your screen, you should see something like this. Oh, sorry. It's actually here. Sorry. Ooh, interaction panel. What is that? I don't know. First time that I use this software, by the way, so bear with me. You find it here. Oh, you cannot really see it, can you? I'm going to put it like that. You should be able to see it better. And there's also the QR code next to it. But what you should be seeing is a set of questions. It's like, it's up to you to make the content. So yes, it's your fault if it's gonna go bad, and it's just my awesomeness if it goes well. But anyway, you will see a lot of questions on the board, on the screen, and you should be able to select 3 of them and rank them in the order that you prefer. And I would like to invite you to do so. Once we have those questions and you selected what you want to talk about, we're gonna go into them, and I'm gonna ask some questions more about those topics. I see that 3 participants are ranking, 1 participant is still ranking. Stuff is happening. Oh, okay. Things are gonna start appearing. Ooh, exciting. By the way, sorry, the number before the question are just for me to know what to pull and what to put. It's not an indication of how important the questions are. It was just an order for me to do things. I'm gonna give you a little bit more time. There's 1 person more that is ranking. Oh, 2 more that are ranking. All right. Thank you very much. I'm going to call it here. Oh, there's still 1 participant ranking. Well, it's okay. We will see what happens. But thank you very much. I'm going to call it here, and let's start the discussion. So one of the things that we want to talk about is it will never be possible to fully disentangle neuronal and physiological data. Awesome. I have another poll here that is going to go on now. And yes, I was prepared. I knew you would like to talk about it. But you should see now a new poll. And so how the session is going to go is that I'm going to ask you if you agree with this sentence or if you disagree with this sentence. And if you're a person that actually does agree with this sentence, please try to disagree with this sentence because it's going to be fun. Once you decided what you prefer, I'm going to call somebody that voted yes and somebody that voted no. And we're going to see them fight. And they told me that we cannot spill blood on the carpet. So we're going to just try to do it like, like just joints and stuff. But yeah, let's see. I'm going to give you a couple of seconds more to decide. Oh, okay.
So you want us to try to disagree
With yourself.
with ourselves?
Absolutely. Yes. Yeah, we were talking about this before. It's like we're gonna do gladiator style. The last person alive is the winner. And then you can go to the future of fMRI because you survived. All right. Okay. May I ask? Okay. So apparently there's a little bit of a bias toward I agree. Okay. Who is agreeing with this question, with this statement? I'm going to ask at least one of you, if not 2, to come here at the stage and join me. Don't be shy. Please come. It's fine. Otherwise, I'm going to call. Oh, I'm going to call then. That's fine. Raise your hand again for a second. Who agreed with this sentence? All right. Sarah, you're coming up. Daniel, you're coming up. And sorry, Leah and Dan, it's just because later we will see you, but... Who disagreed with this question? Great. Molly, Benoit, right? Please come and join us to the stage. And give it an applause to the first set of volunteers that decided to join us here. All right, teams. I'm gonna give you some minutes to think about it. And by the way, sorry, they're here because I needed some, basically guinea pigs. But in the audience, if you have something to say, just scream out loud. If you have questions, just raise your hand, and we're gonna try to do it with a lot of participation. Okay, Sara Lea, why do you think it will never be possible to fully disentangle neuronal and physiological data?
I guess from like a trainee perspective, not having like a ton of knowledge in the field, but like just with dealing with low frequency and high frequency physiological signals, it's always extremely hard to separate the two. And I think that regardless of what you're doing, spatially or temporally, there's always some kind of underlying issue. And I think maybe it'll improve as our TRs get higher and we can maybe build better models. That I don't know. But I guess just from that perspective, I find it's very hard to disentangle physio and fMRI. And we see a lot of relationship with our physiological signals in fMRI in a lot of the regions that build networks. So to me, it's just very difficult to imagine that they can be truly discoupled.
Yeah, that's a good point. I was just going to say, yeah, we're not sampling fast enough. And even if we were sampling fast enough, like partial volume effects and other things will make it really hard to know where exactly is what. So we would have to measure every molecule at every microsecond.
Molly, Benoit, how can we disentangle these informations?
The people in the future are going to be way smarter than we are. And I think we're discounting the idea. I'm saying this with great conviction now. We're discounting the idea that there will be a stimulus in a pathology that allows these things to become uncoupled the way they are very coupled in most of us here. And when we find those unique cases, those patients who are identified by initials because they have such unique physiology, we can learn so much from them. So I think that I will not discount the idea that regardless of amazing improvements in our measurement techniques, I think that actually we will encounter experimental designs, conditions, and individuals that will provide opportunities to disentangle aspects that are typically entangled.
Benoit, do you want to add something?
Not that great. I think there is no theoretical reason we should not be able to disentangle them. So yes, with some tests, new techniques, new approaches, with some time, at some point we'll be able to disentangle them.
Right.
Because that's theoretically possible.
Do you think there's a technique that can help? I'm sorry, I'm asking these questions because actually that's going to be my project for the next 2 years. So actually, please give me the solution now. But do you think there's going to be a technique that will be helpful to do this task?
I think it would be probably several techniques in the same time, not using only one methodology. For example, using fMRI is one technique. Having external recordings allow us to disentangle a bit the signal we have from a different measure. Maybe we'll have a new machine, new paradigm, new experiments that will add a new source of information that will allow to disentangle this problem.
Right. Okay. Thank you very much.
I just don't know which one.
It's fine. We're gonna find it together. It's okay. I saw a hand raised here. If you
just wanted to clarify what do you mean by neuronal and physiological processes, because depending, someone mentioned like fMRI bold, and so is it mostly central things, or are you clarify the question?
So they asked me to clarify what we mean by neuronal and physiological data. I'm actually gonna bring it back to the. It's up to you to fight and convince us that your point is right. So how do you want to interpret that information? How do you want to interpret neuronal?
You just don't want to answer the question.
No, I don't want to answer the question, but that's why you're here.
I mean, is this like a debate club? There's like because then I would say it's the worst measurement that you could possibly get.
There you go.
But it's like really hard because
you phrased this question with two extreme words.
Right.
Never and fully.
Right.
Yeah.
Both in contradiction to each other. So they emphasize blunt answer never. Said, oh, never exactly. He said someday. And they said, well, not fully.
We both disagree with the premise.
Well, which word are they going to catch on to?
Yeah.
Right. I mean, but that's the fun of a debate. Give great spaces to talk. Okay, so in order to, maybe I'm going to answer to you. So somebody, as Mark Guy a couple of days ago said that actually physiological data can be thought, or at least gave us the idea that physiological data can be thought as neuroimaging, right? Because there are processes between like top-bottom processes and top-down processes that are involved. I think that here by neuronal, and by the way, sorry, I failed to mention this, but all of these questions didn't came from me. They came from our amazing community, in particular, shout out to Ines Steves, that gave us these nice topics to talk about. And so that's why I don't want to answer questions. But I think that here by neuronal and physiological data, we mean in the brain itself, right? And so when we are like what we're trying to do as OHPM, as like cognitive neuroscientists, is capture what the neurons are doing. And what is in the middle for us, it's physiology, right? Because for instance, our techniques are based on metabolism. And so there's just physiological processes going on. But also there are physiological processes that can overlap with those cognitive and neuronal information, right?
Because, for instance, as people doing EEG, for them, the question would be, the answer would be slightly different because there is the electrical activity that they capture is much differently impacted by physiological activity, and so it's not as convoluted. It's a different time scale, and so it's even easier, I would say, to make those processes. So that's why it's really it seemed like a fMRI focused biased question.
No, actually, that was part of the conversation. So basically, Dom is doing the job of Molly and Benoit, but that's great, right? And I think that Molly is happy. But yeah, no, like Dom was raising the point that this is probably like maybe biased by a method that is metabolic in nature, and actually for a method that is not, and so EEG. This is maybe a bit more easy to disentangle.
I think I will disagree in that now I think we're at this meeting increasingly talking about systems that neurally control or interact with systemic physiology. So effects that sort of poke one end of that stick have repercussions on the other end, right? So that disentangling is difficult even in EEG. So I don't actually think it has to be an fMRI-centric question at all once we consider those relationships, not just signal confounds and interpretation, right? But actually about the physiology itself. I mean, that being said, my lab says there's a bit of physiology that's frustrating and we want to be in charge of. So we have a system that controls blood gases. And I could imagine using fancy things I don't understand, like optogenetics in animals. We can do things to influence the brainstem to uncouple certain aspects of some of these systems. So I think it is hard, and you can't maybe disentangle everything all at once, but perhaps agnostic to measurement. I think those types of strategies give me a tiny bit of hope. I'm on this side because he told me I had to be on this side. I think it's wicked hard.
Yeah, I think it's really difficult. We do work with EEG. We do fMRI, EEG simultaneous collection, and we still see such similar patterns with physiology as we do with EEG. So they definitely have some different signatures in some ways, but I feel like there's just so much overlap that we still haven't figured out how to disentangle them, even though we do try a bit. So yeah, I still argue it's difficult.
Follow up thing that was advocated, but in that for that argument, no, but by saying that even the question begs for the assumption that the brain and the body are two kind of decoupled things. You said, theoretically it's possible to disentangle, and that's a debatable point. I think, like there is such a tight coupling between the physiological activity and the brain that, I mean, even on theoretical basis, I'm not sure that these are two things that we could possibly disentangle. I'm not sure that a patient, human living, could exist that has this uncoupling.
No, but that's saying that you have to uncouple everything in one experiment. And that is not how I think it's going to happen. I think it's going to be about the relationship of this heart rate response and this breathing effect with that overall, arousal change, et cetera. That one element could be distinguished in one experiment, building overall a framework for how these things interact across experiments. But yeah, in one person, that patient's probably dead.
I have a bonus question because that's actually something that Leah, you brought up, and Sarah also you brought up. You were talking about fast sampling, right? And do you think that fast sampling could be a way in which we can, fast sampling, this is definitely biased toward MRI because the EEG is already fast sampling, but do you think fast sampling in MRI would be able to give us that edge to be able to, at the very least, model physiology versus cognitive, or maybe the solution is somewhere else, like fast TR is not the best way to go for this kind of model, and maybe long TR, but different techniques can do a similar job. What's your take on that? Whoever wants to respond, doesn't matter the themes.
Yeah, okay, so the thing is, you have this huge dynamic system, right? And every perturbation is going to affect some part of it and is going to have these huge repercussions. If you want to estimate that, of course, the more data you have, the more you can get into that. I think the problem we run into, and I think, or the thing that I would want to know, which I don't know, is people have been doing line scanning and these experiments with fMRI for many decades, right? Where they just scan a tiny part very quickly. But I think it's the intrinsic smoothness of the signal which will make estimating stuff hard regardless. I don't know, you probably know more about this than I do.
I think that's, yeah, I agree. If anybody else has something to say, I'm still kind of thinking on my thought.
All right. Do you want to add something?
There was I think the community is a bit more into the gut-brain synchronicity, and this has been shown in some articles that some part of the pulse signal is explained by this external measures. So I think this is another way to tackle this problem between synchronicity of the signals.
Right.
Now we have a new source of signals that can explain these variations, and maybe with also fast sampling, it can help to. I know we are limited by the hemodynamic response function. Maybe we will have in the future a better model that can decouple this hemodynamic response function from different external sources of signals. So we have something more purely neuronal, should I say.
Makes sense to me. Hey guys, thank you very much for joining me on the table. I will let you go. You did a great job. Both of you won. I don't know. Another applause, please, for our first guinea pigs. All right, question number 2 that should be going on in this moment. Oh, wait, I have to reset. All right, so you should now be able to see another poll. Physiological measures are behavioral measures and confounds. Collecting the data, even if you don't remove these signals later, is important. You won't know if people hold their breath at the same point of a task event. And I think that here, the point that we're going to follow is basically collecting the data, the point of collecting the data and looking at it. Hey, apparently nobody's debating on this one. We all agree, but okay, yes, we all agree. Is there somebody that wants to come up and debate for the false? Somebody that has a very strong opinion that physiological measures, first of all, are not behavioral measure or confounds, or that collecting the data is not that important? Leah, yeah, sure. Hey.
expensive, it adds to the scan time, right? You need extra approval from the ethics committee and so on. So it's actually, and the usefulness right now is limited, right? So like, how do we convince funders that like it doesn't really add that much? That would be my only counterpoint.
So Leah is,
Like a good debate to me.
yeah, also to me. So Leah was saying, yeah, it's difficult, it's expensive, like there's a limited amount of things that we can do with those data, and so how do we convince our founders to go for it, basically? Which is a good point, if somebody wants to answer. But please, if you can comment, do it in the microphone. Sorry, because guys, like we're also recording this session, and so we're also streaming it online, and you're saying very important stuff, but they only listen my blabbers and my voice, which is very, like, it's worse.
So there's a few points on that. Like as far as convincing funders, if you wanted to buy like a standalone physiological recording system, like your own biopack system, with everything to do just basic respiration and cardiac, that's less than $10,000, which is like a week of scan time on most MRI centers. And if buying that means you don't throw out a massive amount of your data, it is, so just the cost perspective, it is cost beneficial. So if you want good data and you can, if you ask your funders, do you care that our data is useful? And then it is a fraction of the total cost of running a scanner to get closer to useful data. And as far as like hard to collect, I've heard this so often. You do have to like learn a little bit, but once it's part of your routine and once everyone says like, of course you do it, it's just not at least a belt around the chest and a pulse ox around the finger. There's a little bit you got to learn of how to get it right so it's stable and it's not going to be totally noisy. But once you learn it, it just becomes part of your routine. It's not that big a deal. I've done it on elderly. I've seen it's done on kids. There's other stuff that is harder. So like if you want to do like end tidal CO2 and you're putting nasal cannulas or other things, people, yeah, that's hard. But if you just want to say like, did my participants hold their breath every time, like the test came on, that is really easy. And one of my dissertation studies had a part where I was doing, less than a second, 3 seconds, 6 second, 12-second checkerboards. I was going to do this great study on non-linearity of the bulge response. And it turned out a non-trivial number of my subjects just held the breath for the duration of the checkerboard. And the results were beautiful because I was getting robust signals across the whole brain that varied by the duration of the checkerboard. And fortunately, that data isn't published unfortunately, that data is not published for my publication count because it was completely a breath hold artifact. So
and vice versa. I think in breath hold we see a lot of confounding effects. That is the other way around, right? So we see responses in the visual area that we don't know if they're just because the subjects are looking at the screen and reading something or actually doing the task. So
I'm just arguing to bring up another discussion point. So a lot of times, especially if you're starting out, or even if you have been doing it for a while, you have a lot of signal dropout, or you just miss signal, or somebody moves and you get a lot of artifact. And if you're really interested in the continuous aspect of the signal, a lot of times that can completely get thrown away because we don't really have anything that's really good at interpolating over all of these artifacts. So kind of like on the trend of like, it is a lot of work. Like what happens if like you really do have a really hard time getting continuous solid signal and you don't have any way to fix it? That's just open for discussion mostly.
sorry guys, I know I'm adding a lot of steps to your count steps, but it's limit of technology.
I just wanted to ask a question to you both, I suppose. Would it be in principle possible to run an actual study to quantify in terms of like, financial benefits, how much physio can be, used to recover noisy, noisy chunks or something like this? Like, would such a study be worth it?
I think physio recovering is definitely worth it. I don't know a lot of what would go into the cost benefit analysis of that, but I think it would be interesting.
Yeah, I mean, I'd have to think of like what the study outcome would be besides that, you're going to be using, you're guaranteed that there's 10 data sets that you won't use for good reason. and that's the cost benefit. That, you know, there's a bad run, there's a bad thing that you can remove, and that pays for itself. Your data is going to be a little bit better quality. Like, that's the thing. Like, denoising is tricky. The method where we all have our preferred method for denoising, and they're all wrong. I mean, some are better in applications, some are worse, some are noisy, some are not, but none of them are perfect. So I think there is a benefit when you do that stuff, but that is a little bit more challenging, but doable. But just saying, collect it and look at it, and, you know, say, hey, volunteer, you're holding your breath. Can you try to breathe more regularly? That I don't know how to do, like, you know, quantify that, but it pays for itself pretty quickly, because they just, you know, some of the scanners even just come with this as a default. Like, it very often, like, it would be sitting like in a back closet. I know that the Siemens ones has actually some issues with like using it as a default. So you gotta be a little tricky, but like often, like, you buy the scanner, it's sitting there, and no one really noticed it's just sitting on a back shelf.
Any other question? Anything that you want to add? If not, thank you very much again. One more question, maybe. So you should be seeing now on your screen a new question, or at least a new sentence. Multimodal fusion of physiological data is the crucial step to advance the neuroimaging field. Oh, and yeah, and if you just joined, you can, if you want, you can just go to slido.com and enter the number, or you can also just scan the QR code. I know it's a bit little, but let me see if I can make it bigger for you. It's not a matter, no? No, I cannot. Sorry. Did my best. In the meantime, Ines, are you online? Yes. Hey, Ines, do you want to come on the screen, please? I assume that Ines doesn't want to come on the screen.
She writes yes, but then she rejected. So let's try.
I'm sorry, I'm just doing this because I have. Thank you very much. I have no idea. I have no idea how to interpret this question. So if you have any question, Ines will be able to.
She rejected again. Maybe there are some problems.
And just to be clear, Ines, you should be able to share your screen and share your camera in the settings of your tab, and probably that's why we cannot get you.
She's refusing it.
Okay, you're refusing it. That's fine.
About joining.
All right. So maybe you can just write a comment about what you meant for this question, because again, Ines is the person that gave us all of these beautiful things to discuss about. In the meantime, who said false? Nobody. Silence. All of the attendees online said false, right? Who said true? Come in. One. Anybody else that wants to come? Sure, Francois. Benoit, come up. Sarah, come up. Hi, what's your name?
James.
James. Nice to meet you. All right, guys. Convince us that this sentence is true. First of all, if you can explain me what this sentence means, and then convince me that it's true.
Okay, well, I suppose I'm sat down first. So, multimodal. I've now lost the written question, so I've forgotten what it was. But multimodal fusion with physiological.
Multimodal fusion of physiological data is a crucial step to advance the neuroimaging field.
So I ought to express like a kind of disclosure that's kind of been my whole area of research for about 3.5 years as a PhD student. So with that disclosure in mind, I think for me, I'd answer the question through like what the objective of the whole of neuroimaging is. Like, what are we actually trying to learn from imaging the brain? And for me, actually, I've although that's been my area of research, I've actually been kind of disappointed. I've been looking at kind of some of the more challenging mental health disorders to kind of see with the modalities of brain images that we use today. So I've been unconvinced actually by kind of subtyping depression, for example, through the current images we have today, because I'm not sure we're actually capturing things that relate to, it's hard to capture social interactions with neuroimaging today. But notwithstanding that, I think that if we did capture the right neuroimaging modalities and the right scenes and the right the right forms of data, in order to interpret those data, we would still need other information that exists outside of our heads, and that's probably where I'd stop and pitch my answer.
Sarah Francois, do you want to add something?
Yeah, sure.
Is that for me?
That's for you. That's brilliant.
James. Because in my mind, it's relatively simple. The underlying goal of neuroimaging research in general is to get to know the whole nervous system, right? Not just the brain itself as this isolate organ of the human organism. And so to me, if I go with my interpretation of what multimodal fusion would mean, would be integrating the different physiological or peripheral physiological modalities of the nervous system, right? So everyone knows about the autonomic nervous system, right? And its relationship to brain activity under task, but also resting states, right? So I've been interested in the literature regarding brain art interaction, for example, and we see that there's a reciprocity between the activity that we infer from art rate variability of the autonomous nervous system and activities of regions of the central autonomous nervous network. So a work by Critchley and folks such as these that are essentially describing the relationship between parasympathetic and sympathetic activity of the autonomous nervous system and central nervous system activity. And so fusing all of these sensors together, for instance, we could have a more detailed picture of what regions of the central what regions of the brain are interacting more directly or more closely with the autonomous nervous system, right? So let's say, for example, cardiorespiratory pattern. Is there specific cardiorespiratory activity that could help us disentangle this interaction between art and the art activity and, for example, fMRI, as we all know that these are both vascular measures.
Okay, thank you very much, Ms. Sarah. Do you want to add something?
Yeah, I think just one of the overall main goals of, especially with like functional MRI, trying to understand it is knowing where your signal comes from in general. And I think that the only way that really you can decide what's best to do for your data for your analysis is to really understand a lot of where the signal you're interested in is coming from. And I think that the only way we're going to be able to do that is through multimodal fusion, whether it's with EEG or physiological peripheral collection or any other kind of modality that you use to kind of just better understand and explain what you're seeing in regions as we continue to grow as a field. Yeah, that's really all I have to add to that is kind of my take on that. I agree with everything that's been said.
Yeah, there's a biased
James,
panel here.
Last point, and then
I'm sort of
actually-
kind of wondering if maybe a question in the room, but to some extent, is would people consider if we did a task-based fMRI where we scan people as they looking at different images or whatever, would people consider the something like predicting the task based on the fMRI data? Would people consider that to be fusion?
Good question.
Because I would, but I recognise that's I'm probably pushing people's perspective on what fusion is. But if you certainly, if I take that as my kind of, I'm finding covariance between two different types of data, which I am. So if I use that as my definition, which is quite wide, then almost every single poster that I've just been looking at before coming here is fusion, and that kind of reflects sort of my answer.
Yeah.
Everyone is doing it, so it must be.
Yeah, a lot of the debate is around choosing the right words, actually.
Yeah.
And I guess if we're dealing with that challenge as of today, it's because the research effort towards these types of signals has been quite undermined, or there must be some kind of incentive structure that can explain that this discrepancy between the semantics of, let's say, central nervous system debate and debates regarding peripheral activity or whatever modality fusion we can talk about. Right? For sure.
Thank you very much, guys. I think that we have to jump, and then I see. Yeah. Do we have time to? If Dan, you're okay with that, then yes. But then you have to come to the microphone. Right. Maybe 1 point more. Just 1 or 2 points more, and then. So in the meantime, I'm gonna take advantage of the fact that people are moving around. So we're gonna close the hour debate after these couple of back and forth. So thank you very much for joining. Sorry, I can see the screen and the other way around, and it's okay. But yeah, so first of all, thank you. I want to say thanks to these beautiful people because, once again, they're the reason we're here doing this. If you want, we meet every third Thursday of the month at 4 UTC. You're free to join us. We don't do this kind of stuff all the time. We're actually doing more sensible things. And we're going to have a meeting on the August 3rd. It's still at 4 UTC. And if you want to join, please join. I'm just going to, while we finish chatting, there's a new question in your app, in your poll, that I would like to hear about. And you don't have to argue anymore, so you can answer friendlily. Physiological signal, friend or foe? Okay, so Mary, you wanted to...
Yeah, so I think like a lot of people challenged by the wording of the question. And we were just talking about what counted as fusion. So when I read the question, I interpreted it as fusion of different kinds of physiologic data.
Right.
And so I was curious as to what people would say as far as which kinds of physiological data are crucial to collect and fuse together to advance the field. We talk a lot about PPG and or pulse and respiration, depending on how you collect pulse. But is that enough? Are those two in a unified framework crucial to advance the field? How much should we be looking at these things separately? What kinds of signals should we be looking at?
Together, yeah.
Anybody wants to comment?
I feel like in the best case scenario, you would want everything that you can potentially get. But obviously that's really difficult to do. But I think that, I think that that's a really tough question because a lot of times it just kind of comes down to expertise and training that you've had. And PPG and respiratory belt are pretty easy, user-friendly to do. But if you're going to do blood gases, it requires a lot of work, a lot of knowledge on how to set that up. And then if you branch out to the skin galvanized, whatever, I can't remember the name of it.
Electrodermal
activity. On your skin, the sweat one that you were talking about. Can't remember the name of it, but yeah, like that. It's like I think that there is no right answer because I feel like I just don't know, and I think it's really hard. But in the best case scenario, you'd want to have as much as you can.
And yeah, and to add on to that, these like technical challenge of processing the signals, I just want to say, I just want to get it out of my end because, you know, when you're looking at unidimensional signals on a graph, you're like, well, that's pretty simple, you know? It's just a signal. It's just a time series. But that's not the signal of interest for most physiological modalities. For PPG or ECG, you're looking at interbeat intervals. So you must detect peaks. And for that, you must apply algorithms. So yeah, I want to thank my friend Dominic, who's just like merging and reverse engineering processing pipelines for each type of signals and providing the community with like a project that is inclusive and encouraging people to do the same. And I guess it brings me hope that knowing that there's a project like that, because we can put our resources together that way. If I'm doing just my little thing in my lab, maybe I can help someone else. And if like 10 years down the line, we merge all of these resources, now it's not so unrealistic to think that we can integrate all of these modalities, right, in one modeling scheme, right? So
All right. Thank you very much. I saw a raised hand, but yeah.
Due to this like domain of physiological like measurements and I mean, it makes sense for like diffusion and gold, but is there any like utility currently that we're aware of at least in the field for like anatomical data or diffusion like the TTI data or?
Okay, so the question is there any utility of physiological data for anatomical information? Like we're talking about BOLD, we're talking about EEG, we're talking about functional, that's great, but what about structural? What about DTI? What about this stuff? So I'm gonna answer by asking Molly to answer this question. She's always the person that asks, like, you know, to answer this question about. But in the meantime, thank you very much. We're gonna change the table as well in the meantime because we can go on rolling. If you can just share the screen for a second. Physiological signal, friend of foe, friend. Nice. Molly.
Just because I wanted to bring it back to Physiopy.
Thank you.
I don't do it, but I think all of that variability is in structural data and structural data is kind of required. How exactly you incorporate it, and is it the limiting factor just in your having interpretable stability? Typically, no, but at some point, there's something will be taken into account that you
I just want to see my questions.
I don't know why you think
We're good.
it's like thinking like in regards to like signal university has like downloading in software that I'm aware of that's out there. It's like something capturing signal changes over time intentionally as opposed to interactive.
Right. Yeah. What I can tell you is that for DTI, there are softwares that are starting to do physiological corrections as well. So it's not something just for us. So it makes sense. All right. Thank you very much. Dan, the floor is yours.
Okay. Yay. So we kind of split the session into two, and it's going a little bit longer till about I guess 4:15. The idea on this second part of this is there's a lot of, especially in scientific specialized software, there's a lot of small groups with sort of very specialized skills trying to make a communal resource. And very often, you know, especially in this crowd, it's all open science. Yay, everything's great, everything's wonderful. But like when it actually comes down to like making these projects work and sustaining these projects, there are challenges. And I think we're much better talking about the challenges, talking about the things that are genuine problems, talking about ways several of us have succeeded around those problems and ways that we haven't succeeded. So the idea of this session is to bring in a panel of people who have been involved with several of these small software projects to discuss these issues. So I am not pulling people from the audience like Stefano did, but we found people in advance. But if other people here want to come in, join up as we go, you are more than welcome. Of this group here, we have 4 different of these small packages represented. There's Tirana, which is software for multi-echo fMRI noise removal. I'm involved with that, and Neha's involved with that, and Stefano, I guess I could say, was involved with that. And it's been around since 2017, built off some older code that was kind of orphaned. At any given time, there's been about 2 to 5 active people writing code for it. But over the years, that's been about 28 total, and we have a bunch of other people that have been very actively involved, but not in the code. I guess you want to each introduce your own package instead of me, and so, yeah.
Okay, so I think the next one is Enigma half-pipe. So in the Enigma consortium, we wanted to expand to functional MRI because it's a big consortium that does like genetics, meta-analyses across different sites where they all process the data in the same way. For structure since 2010, but for functional, it's of course a bit more involved. We wanted to make it current with fMRI prep and so on. So we started out with 2 student assistants in 2017. I came on board in 2020 as a developer, and we kind of finished something. But it's been a really small project. We now have funding to hire a full-time developer. But yeah, it's still basically me and some student assistants.
So I'm involved in NeuroKit. So NeuroKit was initially, NeuroKit 1 was actually a side PhD project that I created to both to learn Python and to also because I needed some things to process my own physiological data. And so, you know, it was an initial kind of draft of that, which implementation was not very, I wouldn't say professional, but wasn't, you know, not necessarily the neater and the most clean kind of implementation of a package. And then in 2020, 2019. Yeah, I mean, it was just before or like when COVID started. That's why we kind of reforged. And so there's some people that were following NeuroKit 1 kind of tuned in. And with, you know, a bunch of people, we kind of created a new package from scratch, and this over time this went well. We have many kind of one-time contributors mostly. Currently there's like 2 active maintainers, and yeah, that's about it.
I guess. Oh, yeah.
Oh, I'm Steph. I already talked about Physiopy for 45 minutes. Skip me.
Okay. So the first question is, what did it take to get a new small project? I guess there's 2 things. For the people here who have written projects in the beginning, what did it take to get a new small project off the ground? And for those of you who joined midway, what was it like to sort of enter a project like this when you entered? Or I could start. Yeah. So for Tirana, I was actually tangential member. I was there from the beginning, but I was a bit more tangential at the beginning. So Elizabeth Dupre and Taylor Sallow really did the heavy lifting at the beginning. And I was much more of an advisor. And in some ways, I would say it was a fake it till you make it. So like they were starting with existing code that was a mess. And they built it up and they built a lot of excitement and got a lot of people involved. But then they did the hard work of saying, okay, now that we got people's attention, now that we got the parts, what do we actually need to do to get this moving forward? And that's really what it took to get started. Like regular meetings from the beginning, they were very into sort of making onboarding documents. So if you look at the Tirana documentation, it is full of stuff on like how to make your first contribution to GitHub, how to do this, how to join in, because they wanted from the beginning to try to make it a project that would attract other contributors.
Yeah, something that I also can mention is that for me personally, like the the social aspect of GitHub also played a definitely a role. And I believe, many labs have their own kind of scripts, internal code, which are often sometimes a bit messy. It's passed around from researcher to researcher. And for me, because I wanted to put this online, open access, because I knew that, it might maybe benefit someone somewhere out there. But the fact of putting it online also made you want to make it accessible. So it forces you to write maybe something cleaner, to document it better, and this in turn then helps the visibility of the thing and the usage and the usability. So yeah, to put your things out there, and yeah.
Yeah, I think for us, I think what we started out with was focusing on the users, like also having regular meetings with specifically people from the consortium who would like also test it in a very regular way, so that we would know, okay, this makes sense for people. This is also usable and accessible, and also writing like really step-by-step tutorials for what do all of the options mean, how to use it, and so on. I think we've had trouble like getting new kind of contributors in terms of code, because yeah, I mean, it's a very, very user-focused application. So I think the people that are interested in writing code wouldn't really be interested in I don't know, helping with the user interface to fMRI prep necessarily. So that's been a challenge for us, yeah, motivating people. So I think there's lots of stuff that we can learn from, also in terms of what you guys mentioned. So we'll be interested to hear more.
So I've been a part of the Tadana team for about a year. I actually joined seeing a Tadana-related Emergent session last year. So my experience is a bit different. Tadana had a pretty big update release just a few months ago. So when I joined, that was kind of one of the main projects ongoing. So I think on one side, it can be kind of tough not knowing like the history of a long project and, where it's gone and kind of what the goals are for it. But at the same time, it was nice that there was an existing project with some specific goals that I could help out with. So I think those are kind of both sides of joining a project when there's been, some ongoing work.
Neha, you're the contributor that everybody wants to have, because it's like having somebody that tests your code and does a lot of stuff like that. It's just awesome. It's interesting because I have both perspective as a person that joined in the middle of something with Tadana and then started something new with Physiopy. As the person that joined Tadana, it was rough, because I remember I was interested in doing multi-echo fMRI, and that was what brought me to the community. And then we met at a hackathon, and somebody just took me there and said, "It's fine. You don't know how to do Python. You don't know how to do Git. That's okay. Sit in front of me, do what you can, and then when you have a question, just ask me." And I think that Taylor was crucial for me, not just to get into the Tadana, but then to do everything else. But then I took that experience with me, and when I started Physiopy, I was like, I'm not going to do this alone. Like, there was a niche and there was a need that I was working on that was basically bitsifying physiological data, and that was because I needed it. But then I was like, but then it's not just me that needs it, and it's not just me that can do something about it. And so I reached out. And I reached out to Molly and her lab, and actually, Molly is the only one that was there at the first meeting with me in this room. But we were like 8 folks in DC called Convergence, and we were just in a side room, and we were like, "Hi, what do we do?" And that's how we started. And I think that the thing that helped us was, first of all, understanding what was the need of the general community to focus on stuff, what were the skills that we had already there in that room, and what were the skills to bring in. And then we were lucky to have Rose Marcello that helped us a lot with setting up everything in the project and the software, and that kickstarted everything. And then how to, like, the thing that worked for us in terms of getting a new person coming in, I think, like, on my perspective, and actually I would like to hear from all of you, is it was basically just becoming a juggler. It's when I have a coder, just let's do code. When I have a person that knows how to do, like, maybe doesn't know how to do code, but has a lot of knowledge about physiology, let's do documentation. And that's basically what we did in the last 3 years. We just juggled with what the person that comes in can bring to us, right? And what we can bring to them. And so, yeah, it was my experience.
Great.
Mm.
Yeah.
No, maybe I just want to piggyback on that, but also talk about one of the main, as far as I can see, limitation or issue in finding new collaborators. So for, like recently there is, so I mentioned that there is another maintainer that kind of joined and really Danielle, that I would like to acknowledge, because she's been just really helpful in helping. And at some point I asked, like, what do you need in return,
Right.
in a way? And she works in the industry, so she said for nothing, but I felt almost not bad in a way, but it made me really think about, because like NeuroKit, has can be cited, and yet many new contributors that could join the project doesn't benefit from that. And so, and I'm really thinking hard about what are the solutions to this kind of stuff. So there are some solutions, like having like a citation kind of that changes every time there's a new contributor, but this is, it's clunky, and it doesn't also scale well with, at some point when you have like, it doesn't take into account like the number of contributions. So it's just a very complicated issue. And I can understand why someone like a fresh PhD, for instance, they have the choice. Maybe they would start creating their own little project, and they're like, oh, maybe it works, maybe I will definitely benefit, rather than joining a already existing project and not maybe have, all the necessary kind of academic benefits from it. So this is really, like, for me, like one of the big problem in software development in academia is how to credit correctly the people that contribute.
And we're kind of jumping into two of the other questions, so I'll just say the
apologies.
questions. No, I'll say the questions because it's flowing naturally. So one is, how do we deal with changes in contributors? Like, when you have 2 or 3, 4, how do you deal with changes? And then the parallel question was, how do you support contributors coming in with diverse strengths and gaps? And I'll say that this has been like the biggest challenge for Tadana, because no one is going to enter this project. Like, Tadana is a project that benefits from expertise in advanced methods processing, MRI physics, and advanced software coding. And having someone saying, I want to contribute, who comes in with all those skills, is effectively no one. In fact, I would say most of our active contributors have only 2 of those 3 at most. So it's making a project where someone comes up to us and says, I want to contribute, but I obviously don't know what I need to know. And working with them to say, no, you're in the same boat as us, and finding ways to bring people in is really hard, because there's sort of you have to get people over that sort of mental hurdle of, I can't do it, because the answer is no, you can't, and neither can I. And then give them the resources to help them make their parts. So in the Tadana example, we've done a lot of work on putting educational material on the website. We've tried to keep a very active presence on sort of the NeuroStars Q&A, so that like people have it on board. And whenever someone comes in and says they want to contribute, which doesn't, it doesn't happen that much. Like, maybe 1 or 2 people a year is like, hey, I'm interested. Thank you, Neha. And it's finding the right starting point. So like, we were releasing this new thing, and what we really, really needed was someone to just take the different versions of the program and run it and compare and rigorously test it. And that was a great start, and it was incredibly helpful, and it was critical for the steps. And that's just an example of how to bring someone on. But it really is a challenge, because they're really, we don't want perfect people. We're not looking for perfect people, because they don't exist. And finding the people who are bringing something of value and helping them build up the areas where they know their weakness and is a challenge. And we try our best, and sometimes we succeed and sometimes we don't.
So I can speak to that a bit more as a newer, just 1 year on Tadana. So I was kind of reflecting on what were the challenges or what went well in my experience joining Tadana in the last year. I think, so one aspect I think is like some of the technical skills needed, like Dan was talking about. So for example, for me, I had used Tadana widely. I had collected multi-echo data sets and used it. So I had a lot of experience on that side. And that helped, I think, finding a role of, a need for testing. I could do that quite easily. But something I'm still learning, and one of my main barriers, is using GitHub in the way that Tadana community uses it. Because I've used it on my own code a bit with my lab, but I've never worked on a project with so many active collaborators to a GitHub repo before, and kind of I know what I want to do to the code sometimes, but it takes a while to learn how to use GitHub to do that thing to the code, and especially Tadana has a lot of documentation on how to do it, like the process and the standards to follow to contribute to Tadana properly, but there's a lot to read through and a lot to just, try to make sure you're doing it properly the first time. So I think that's still something I'm learning, and I kind of identifying what those things are with new people can be helpful, and maybe even checking in honestly after a couple of months, because I think it took a little while for me to also understand what the skills were that were needed to be a part of this specific community. And then I'll say that I think the second challenge is dynamic, because I think becoming a part of the team also helps to know, to be comfortable asking for help or to know who to ask for help. And I think the benefit of obviously we have like monthly Zoom calls is that you can work with people, from all over the world, but it can also be hard because you lose some of the interactions in person that make you comfortable asking people for help. So for example, I met Dan last year in person, and it was great because I felt a lot more comfortable asking him for things. But I think maybe facilitating some more of the interpersonal connections too within the group can really help a new contributor feel comfortable as a part of the team, and honestly probably help with retention if that's an issue.
Oh yeah, so what? So I think these are really important things, right? Because talking to people about their skill set and so on seem really important, and also creating this kind of team. So we've also had these regular Q&A meetings with people who are using Halfpipe, and so trying to get people on board. And I think our main challenge has been to get people to stop writing as emails and file GitHub issues, because it's really easy to lose track of an email. But it's really hard to miss that big counter. So we're on 66 right now, which is a lot. But it's just but at least they're not lost, right? They're not lost in some email history. We can go back and fix them once we have the resources. So I think that's one of the big things, to put everything in this ecosystem and to streamline everything. I think the people who file those issues are really important contributors, and it's really, really important to get these detailed descriptions also of errors and problems. The problem is even there, the question is how do you make people feel part of it, and how do you even reward people and so on. And I think it's a very unsolved problem. So one thing I was thinking, maybe just to mail stickers out to people who file an issue in a very nice way or something. We don't have a nice logo yet.
Stefano, for real, I think that the community aspect that Physiopy has is really a good, and the meetings, that's a very good incentive in itself. If people can join and have mind-guided talk to people, we don't have that in as much in but just to I also wanted to acknowledge and the point of it happens a couple of times, I think, that someone sent me directly an email, oh, this doesn't work, or there is an error. And so now I always do could you please open up an issue? And this is a double benefit. First of all, as you said, it makes it easier to track. Yeah. But second of all, oftentimes also they don't necessarily have a GitHub account. So if they go through the trouble, they create a GitHub account, they post, and then we start here. And then maybe I'll be oh, can you then open a PR if a pull request to fix it if it's a simple problem? And then and so I pull them in slowly from the email into the GitHub, which I agree the learning curve is very, very steep. And I think that even with the best documentation, this is something that you really learn by doing over and over again. And so, yeah, so we just have to.
I want to add on to sort of the pushing people towards GitHub. I think it's a little bit of a challenge because Tadana definitely started with the philosophy of everything on GitHub because we we want to bring the people up. But I started the project not really knowing how to use GitHub. I was a complete newbie, and there was a bunch of times I was actively contributing ideas and thoughts, or hey, I found this issue with the code. Here's how you fix it. But I did not know how to do that stuff. So there was a few times I would just be okay, here, and like I was doing common threads on the issues. I was like, okay, here's the 3 lines to fix. Just open the pull request for me. And here's documentation to add, put it in for me. And someone did it, and eventually over the period of 3 years, I'm the person people go to questions. I'm still not great. Like I'm still way far from an expert on GitHub, but I now know enough that people can ask me questions and I can answer them. So I think there's definitely a benefit to pushing people towards using GitHub, but having at least some way to say you're valued without having that skill is really critical.
I mean, sorry. So to jump on top of, like, I think we have a couple of lines at least in my mind open, but to jump on top of that, yeah, it's always difficult, and it's not just Git and GitHub, right? Like Git and GitHub are difficult to understand and develop and like develop a use for. And hey, by the way, shout out to Elizabeth Dupre that made a fantastic tutorial in the Brainiac School about it. And by experience, there's people that are caught by it and will not want to have a beer with you if they're listening to it. But anyway, I think the community part is, yes, what helps out, because then people can just come and say, hey, hi, like, I don't know how to do it. How do I do this? And then you're just sitting down for a second. And for us, what worked very well was hackathons. Like when you're there, like you can just pull them with you and just say, okay, this is how you open a PR. And that's what happened to me, for instance. And that's what happened to other people. And sorry, lost my train of thought, but like, and then like mentoring a little bit, and like the community part helps, and I maxed out on luck in my contributors and the community itself, because then that's where, you get little logos and little stickers and you get the help from everybody else. And that was actually thanks to Tadana. Like Tadana was the inspiration for Physiopy. Like without Tadana, Physiopy would not exist. So thank you very much, first of all. But I think the idea is also opening weekly or monthly meetings in which people can just, jump in and say hi and say, okay, now we do it together, right?
That's
yeah. And then like, I think there was a question or a comment there.
I'll repeat if you're short enough. If it's a brief thing, I'll repeat. If it's longer, come up.
Yeah, in between. I'm a PI who doesn't code anymore, right? And I'm a part of Physiopy, but with a very different utility to a lot of what Physiopy actually needs, and I'm aware of that. But I think something that worked out very nicely is that there's more than one person from my group who have gotten involved. So there are multiple people who already know each other and do similar things with it, who then officially, there's one, get involved. And that, I think there are several examples of that in the community, of there's sort of a hub with multiple users who know each other, see each other daily. And then there are long distance connections as well. And that helps with community, but also very practically with learning these skills.
So I'll repeat what Molly said. Try to into her microphone. The short version is, as a PI, she does no direct contribution to code. But as a PI with several grad students who do contribute, they have kind of their own internal hub. So as a small group, they can advise, consult, and act as sort of like a unit that contributes to the bigger thing. So each of them doesn't have to have all the skills, but together they have that community that contributes to the bigger project. So another comment?
Yeah, beautiful summary of what open source science means for me. But I also want to take another angle on that, maybe a more pessimistic angle, and ask you, like, how difficult is it to maintain such a community? Mm-hmm. There's a lot of efforts put into that, and I don't want to underestimate.
So the question is how difficult it is to maintain a community like this, and the answer is very. There's probably more failed projects than succeeded. Speaking for Tadana, I think it's a mix. I mean, I don't know what Tadana is going to be like in 5 years. I think it's actually in decent shape right now, but I don't know, because we cycle on and off with members. I think we had this coded sprint right the fall before the pandemic. If that didn't happen and brought us all together into a room, I don't think Tirana would exist anymore. So that was completely I mean, it was a lot of planning, but the fact that it happened when it happened was completely luck. Because of my position as a staff, I get to work on this, and it's on my own time, a portion of my own time. If this wasn't that way, it's everyone's part-time project. There's no one whose job it is to manage the software. So it's tenuous. And right now, I would say we had 4 people doing active code contribution a year ago. Right now, I'd say it is me. We have a few other people who are making, we have another person, Taylor, who's doing phenomenal contribution, who's done phenomenal contributions. And anytime I ask anything of him, he's going to do it. He's going to review the code. So he's absolutely critical and very active still. But putting something new into the code right now, that is me. And that's not sustainable. But we're dropping, and then Neha joined last year, and now she's going to ramp up coding. We had 2 more people come. So, but it's always a tennis. Do we get the 2 more grad students to join for the 2 other graduate students that left? And do you have at least someone who can hold the institutional memory? And for our project, the answer right now is yes. But it's right on the edge. That's I think why it was important to have a discussion on the small projects, because it's not all pretty, and it is challenging, and it is risky.
So I guess a follow-up question to that is, what are the guidelines to make that to make it viable?
So I think I'll just continue on that, and then we can have talk a bit. But I think the things there's luck, but I think the big things we've done is try to keep written documentation of everything. So everything important is on GitHub in the issues and the PRs. Every version release, we try to make a good summary of what changed. Every developer call, and I'll say we do them regularly. They're important. They are boring, and I monologue, and I don't like them, but they're critical. But every developer call, I have taken notes. We have a folder with every Google Doc of every meeting. So if I ever leave to something else and we have a gap, that institutional memory is written somewhere. So I think there's no one that is not able, I think the horrible term is the what's it called? The bus factor. So is anyone, if anyone gets hit by the bus, does the project die? Okay. The Google bus factor. The Google bus. Excellent. So this is Elizabeth's specialty. Is she's always the optimist, and she always brings people in with optimism. So it's they get a great job and they leave on the bus. So if any one person leaves, will the project instantly die? And I think if you're that person, finding out a way to not be that person, finding out a way that at least the stuff that really matters is written and shared with someone else, increases the chances it'll survive. And that's increases. It's not guaranteed, but I think Tirana has tried that really hard. We have done at least one full turnover of the people in charge. Yeah.
You want to go first?
No.
So up to you.
I just have a really quick comment about this. It's because right now, I mean, I'm for the project I'm representing here, I'm the bus factor person, right? So, it's really been interesting to see how I'm saying, hey, I'm going to finish soon, I'm going to leave, how that kind of changes things. But it's also daunting, the task of exactly writing everything down, making this sure. And it's also been we had this discussion, should this project just die now? Has it lived enough? Has it done everything? And it's a really hard discussion to have, right? But it's going to be, but we have funding now for a scientific programmer. So if you guys know anyone, or if you want to work on this, please hit me up, or file a GitHub issue with your CV.
Because then you get the job.
And no, I just wanted maybe to mention 2 points, and one of them is for the people that might be interested in the future or might consider trying to create their own project. And I know that, for instance, I really admire the community aspects of Physiopy, and your efforts there, Stefano. But that's something that is also very personal, meaning that I don't like Zoom meetings at all. I try to avoid them whenever I can, and so that's not something that would work for me. And it's also not necessarily a prerequisite in having a successful project, or at least a package. Like I'm also involved in another collection of R packages which have many more active kind of maintainers. And we've been, working very like on a daily basis together. We communicate, but always through GitHub. We never met in person. We never met on Zoom during like 5 years now. And the project is quite successful as well. So it's, it seems it could be a daunting, like don't necessarily project yourself and with the thing like, oh, I need to create a software, plus I need to create a community, plus I need to hold meetings, because that, might be too much. So, go with your guts about what you feel comfortable in. And the second thing was also it's to follow up a bit on the not pessimistic aspect, but the romantic, I would say, aspect is that software is a very, rapidly advancing thing, and the projects, they are born, and at some point they die. And I'm not sure there is very little exceptions of projects that, will stay the same, or even the dominant kind of packages. There is maybe like a few, like staple or that are now so used as a dependency that they're almost integrated like base Python or something like this. But for other kind of more niche packages, it's very, we have to accept that, it might become trendy at some point and then it will die, and, it will be retaken. For instance, when NeuroKit started, there was BioSpy was the main kind of physiological processing software in Python, and now it kind of died. And but we reintegrate, many of the pipelines that they were having, and so they still live through us in a way. So that's the beauty of it.
It's the same for us because
software reincarnation, that's a new concept.
But it's the same for us because, for instance, like one of the main library actually in this moment that is picked that in Physiopy, it was not our project. It was Ross Marcello that was a student, and he did it, and it was a fantastic library, and we loved it. And then Ross said, you know what, I'm not actually working on it anymore. Do you want it? And we were like, absolutely yes. And that's also a way in which basically somehow Pick That died, because that incarnation of that doesn't exist anymore. And in fact, I'm very sorry to Ross, because we are absolutely butchering his software and using it for what it shouldn't be used. But then his work and I would say his inheritance, no, how would you say that?
Lineage.
Its lineage is there, it's surviving, and hopefully one day, thanks to the contributors of Physiopy, will be thriving again. I don't know, but not. So it's not. I don't think it's bad to think that our software will die eventually, right? And the only thing is making sure that maybe something else will be able to learn from our death. And by the way, Google, if you're listening, I'm waiting for the bus.
I'm a bus person for probably a smaller project than all of you guys, but I know because I've met people today who've used my software, and it actually came out of OHBM brain hackathon thing a couple of years ago. So similar stories to what you were describing. So thank you to whoever. But I'm sat thinking, these projects sound to me like at least medium open source projects, like in the sense that you're thinking about having communities around these things. Because to some extent, like over the course of a PhD, you can write useful small open source software without needing any of those things. I reckon it's just kind of a comment really rather than a question, but I do think this definition of small seems to me to be quite big.
So the question comment into the microphone is, there's small, and then there's also like, someone writing open source software as a graduate student, which, just, pretty much on themselves, which is, genuinely small, and the things we're talking about are quite bigger. I think this also relates to the previous question on sort of optimism and pessimism. I think one of the solutions is honesty and openness. So it's both sort of with the community and yourself. So it's, am I writing this project to put in a publication, and I want it to be good enough that when I look at it a few years later, I'll understand what I did. And is that your goal? And if someone else runs with it, then they run with it. And that's a small project and that's a valuable project. Or is your goal to make a community resource that's maintained by multiple people? And deciding that early on, I think, is incredibly important. And as you go, like if your goal is to say, I want a project to go beyond and be passed along other people, there's openness in that as well. For example, when Elizabeth was planning to leave Tirana, she was being increasingly vocal over a period of about 2 years, like, I am not doing this forever. I am really not doing this forever. I'm really, really not doing this next month. And that gave the rest of us an opportunity to say, like, okay, what roles was Elizabeth doing that someone else has to do? And how are we dividing it up? And how are we setting things to essentially keep this project going? And, taking that forward, we've had a bunch of graduate students in their 4th year. And generally on our dev calls, we have some conversation like, hey, how's it going? It's exciting. You're almost graduating. So are you planning to contribute, or should we start contributing, or should we start thinking about what's going to happen when you leave? And again, this doesn't solve it. This is like, I think it's being open that this is hard, and being open that there's problems lets you at least plan and try to say, like, well, it looks like Tirana is going to shut down in a year because everyone's graduating their PhDs and no one's left. Or, well, we have someone else coming in. Let's see if they can fill in roles, or how do we split things? And it's pessimistic to a sense, but you're being open about like what the challenges are. And I think that is a critical thing. Saying if you say everything is wonderful, no one's going to join because you don't need them. No one's going to step up. So being honest, like, no, we really do need something. If you're using this project and you want to see it existing 2 years from now, we need people to step up, is both pessimistic and vital.
Yes. Oh.
No, I was just saying, James, do you want to say what your project is? So maybe someone would be interested.
Okay.
It's called CCA what?
Zoo.
CCA Zoo. Okay,
Ooh,
everyone, use CCA Zoo. Yeah, so I think regarding the project Halfpipe and the Enigma Consortium, it's like we have a huge community that we talk to and we get awesome feedback from, but it's like people who really don't see themselves as coders, right? So the community aspect, in terms of what you were saying, is somewhat divorced from the aspect of getting contributions to the code. And so that's kind of like a separate problem, right? Because if you have people who see themselves as, okay, I want this to work, I don't really care what it does, it's going to make things harder because in the end, then you're just like building this thing and you don't really have that much support also like from like having to kind of really tease out what do people want in terms of the algorithms, what should they do. So I think that's also like a challenge that you run into, right? Because open source kind of means not, you pay for it and you get it. Open source means kind of everyone is involved. And it's been a challenge communicating this and communicating what this means. And specifically in our case, it means that we now ask people who like want to really use this for a big project that they also like, takes this into account, for example, when they apply for grants or when they like plan their projects, that there will be someone supporting us or someone who will be like involved in the coding side, because otherwise this will not be sustainable, right?
So we are over time. Does anyone have like a last thing that's really on their mind? Or okay, so we have one person with last thing on their mind.
I'm really wondering about beyond the time-based resources required to have a community like this. Are there other resources that you have found needed, and how did you get them?
Money.
So resources beyond, yeah.
Do you have money? Can you give me money, please? I'm collecting.
The question was, what resources beyond time do you need? Was the question? Yeah.
Money, publicity, having a logo. I'm not joking. It's part of the solution, because then people recognize you. People try to join and they see the brain. Oh, cool. Then it's like they recognize that you're doing something. People, like, you're doing the job for me, guys. Like, you're doing the good job for me. I'm doing a horrible job, but it's like. But also, it's not just time. It's also like being physically somewhere and doing promotion and being in a lab and like support from API. Like if 2 or 3 labs are taking your software and using it, then your software is starting to grow. I mean, Dominic, you're basically your own PI, so it's like that helps. What else? I don't think about it. Money. I didn't know if I said it before.
So I think what's also maybe important is project management. So like the idea that if you're a PhD student or a coder, right, then you have so many different tasks and kind of this resource that there is someone who has those goals in mind, and that can be the PI, that can be someone else. But I think that's a really important resource, right, that we cannot discount. Like just like having that vision, having someone planning this, like also assigning tasks, assigning priorities. Yeah.
I'm gonna add another one because that's one from Oscar Esteban and the FMRI Prep community. User support, because that's something that FMRI Prep ran a lot on in the early days. That basically they were checking constantly in your stars, and they were saying, okay, there's a question I'm gonna answer, and that helped them a lot. So I guess those are the things that at least I found to be very helpful for a project. And then money.
Thank you everyone for coming.